Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting with another type of AFD, SFD and BMD. Let's see the another type of problem number 2. See, this is another question of AFD, SFD and BMD. The question given in the exam is rigid joint plane frame, draw AFD, SFD and BMD of given frame. As you all knows, our first step will nothing but calculation of support reaction. First, what this is your hinge, this will come 1, this is your VA value and this is your H value, this is your H A, and this is roller support, that's it is VD. Okay, now when we don't know the loads, when we don't know the directions, always assume the towards the point. See, this is we have don't know, we have assumed as a towards the point. This also we don't know, assumed as a towards the point, which is unknown. Now find the reaction over VA and VD. Now how will you find? First, our first step will be support reaction calculation. Now in support reaction calculation, what we will see first, summation moment at A equal to 0 clockwise positive. Now let's see why we are taking moment at A. You can take moment at B also. You are taking moment at A, then this part will be get 0. Now how will you do this? See, this is 15 into 2. This is C. Put a rod over here in A and fix it over at A and apply the 15 kilonewton like this. This rod will bend like clockwise, so it will be 15 into 2 plus. This is 15 into 2. Now after that, see this one, this point load 10 into this distance. See, put a rod over here and apply 10 kilonewton over here. This will also move in clockwise direction. That's why we'll take 10 into this distance. Force into please listen, in this case please take the perpendicular distance, not take 10 into this whole distance. This is not a perpendicular distance, this is only a vertical distance, this is a horizontal distance. Take a force into perpendicular distance and 10 kilonewton, the perpendicular distance will be 2, so we have to take plus 10 into 2 plus 10 into 2. Okay, after that what will become? See, after that, this is VD is unknown. See, put a rod over here and apply the load like this, and this rod will bend like this. This is anti-clockwise direction. So VD into force at perpendicular distance which is this 7. 4 plus 3 is nothing but 7. Minus VD into 7 is equal to 0. Now you get the value of VD. While solving this, you get the value of VD will be 7.14 kilonewton. Okay. This is your VD part in upward direction because it is positive. Now after that we got the value of VD. VD will be 7.14 kilonewton. Now what is unknown here? VA. Now how will we find VA? We have to take the summation Fy equal to 0. Summation Fy equal to 0 upward positive. Okay, summation Fy equal to 0 upward positive. Now see, this is going up plus, this is going down minus, this is also going up plus. Don't take this distance because in summation Fy we only take the vertical distance, not horizontal distance. Okay, see, this is VA plus VA minus 10 plus 7.14 equal to 0. Now we get the value of VA. Your VA value will be 2.86 kilonewton. This is also upward because positive. Okay, now what is unknown for us? 2.86 kilonewton. This is your, now we unknown will be HA also, H value. Now how will you find this? To find the H, always apply the summation Fx equal to 0. Now see, summation Fx equal to 0, this will go positive. left to right will go positive and right to left will be go negative. Okay, now see what is the unknown for us. HA, see, plus HA plus 15 equal to 0. HA plus 15 equal to 0. Now while solving this, you get the value of HA will be minus 15 kilonewton. Minus means your HA will be 15 kilonewton in this directions. Okay, now what you have to do, well, see, this direction is going this side, so directly you have to change the direction of this, because first we don't know the directions of this. Now we got the value minus, means our assumptions will be wrong. See, as you all see, for symmetrical member in x direction only 15 kilonewton is going. To balance this 15 will come this side. Oh, okay, so we can apply this as this side, 15 kilonewton. Okay, please just remember in the exam. You can directly solve, you can directly write over here also, because see, in x direction only 15 kilonewton is going, so towards this direction, see, only 15 kilonewton. Okay, now let's see, after that what will we do, what we have to in previous sum also we have to, after that we have to take the members, individual members, to draw the AFD, SFD and BMD. Okay, now take first one, this AB part. Second one is nothing but consider part AB. Now take second part, consider part AB. Now draw the FBD of AB part. Now draw the FBD of AB part, only AB part, not BCD, AB part only. See, the AB part will be look like this. Okay, this is your A part, this is your A part, and this is your B part. Okay, after that what do you have to do, see, we know the value of this value will be know, and this value also we know. This will go this side, this will go this side. Now see, now see, in free body diagram what we have to do, only draw this. We know the value of this, we have drawn this 2.86, we know the value of HA. Always draw this sign, okay, because we in exam we can know the original diagram. Okay, in original diagram you can draw this 15 kilonewton, not this HA from this direction, because we find we find this tip in the reactions. That's why we have to take this sign, plus, sorry, green one. Okay, not take the red one sign. Now we know the 15 kilonewton is also there. Now see the A part and balance the B part, because as the definition says, every part must be under equilibrium, every point and joint must be under equilibrium. Now take the A part and see the A part and balance the B part. Rest part will be neglected. Don't see this part. After B you can don't see the B part, only we have to see the A and B, and while seeing A you have to balance the part B also. Now how will you balance? In exam you have to balance directly. Okay, now see, your 2.86 coming from this side. To balance this we have to apply here like this, 2.86. okay, now this member will be balanced. Now what about this? See, this 15 is going this direction, this 15 is going this direction, this and this will get cancelled, this will get 0 value, so this is nothing but 0. Okay, now draw the AFD, SFD and BMD. Okay, now how will you draw? See, this is nothing but first you have to draw the AFD part. How do AFD come? See, this is your A part, This is your B part. See, A and B is compressing the member. Compressing means minus, and minus we have drawn inside the frame. Minus will draw inside the frame. So what is the inside the frame? It will come like this. (2.86) minus sign compression. This is your AFD, axial force diagram. Now see, we have got the value of this AFD, we got the AFD. See, always see, minus size means draw inside the frame, draw inside the frame. See, this is will come, this AB part will come minus, we draw inside the frame. Okay, now see, this is inside the frame. After that we have to draw the SFD part. Now how will you draw the SFD part? This is your A, this is your B. Now see, directly you have draw the SFD part also. Okay, directly you can draw the SFD part, while if you want to calculate, you can calculate. If you don't want to calculate, you can directly draw the diagram. See, 15 kilonewton is going up. This will go up 15. See, here also this will come same 15. So straight 15. So 15. After that this will go downward. This downward. In here there is no vertical horizontal load. That's why it will come 0. Now draw the SFD. This SFD will done. This is, see, this is positive. Positive means outside the frame. See, outside the frame. You are standing inside the frame. Okay. Please keep remember these things. Now see, you are seeing over here. Now see, after that we have to draw the bending moment diagram. In bending moment diagram, as you am saying, you always see the original diagram for bending moment diagram. Okay, for bending moment calculation, always see the original diagram. Now we see the original diagram over here. This is you standing inside the frame. You are seeing here, here and here. Okay, now we are seeing here, you are standing in the frame and seeing here AB part. Okay, now in AB part, how will you draw? See, moment at A will be get 0 because in downward of A there is no load, so moment at A will be get 0. But moment at E something is there, moment at B will also something is there. So how will you find out this? Taking bending moment at E. See, bending moment at E is equal to, how will you sign conversion? We can follow these things positive. Okay, now see, put like this, and see, you are taking bending moment over here. Okay, when we are taking bending moment over here, we can see this all frame or we can see this part. What is convenient for us? This part, because this part is very lengthy for us. Always see in bending, as you all know, in bending moment you can see either left or right. We are seeing over here left part. Okay, see, in left part, you are bending moment over here, we are taking this part. This will come 15 into this distance is 2. 15 into 2. Okay, this will come 15 into 2, will get the value 30 kilonewton per meter. This is bending moment at E. Now what about the bending moment at B? Now bending moment at B is equal to, now see, when you are solving the bending moment at B, what we have to do, we can take this part or we can take this whole part. Always we have to take this part. This is shorter span. Okay, see, how will it come? See, 15 into 4 minus this will go, see, this will go like this now, 15 to, so minus 15 into 2, this will come 15 into 4 minus 15 into 2. This also get the 60 minus 30, you get the value 30 kilonewton meter. Okay, kilonewton meter, 30 kilonewton meter. Now you get the bending moment at E. Bending moment E will be this 30 and B will be also get 30. Okay, now A will be 0. Now how will you draw the diagram? You can draw the diagram like this. Okay, this is your bending moment part. Please remember this is positive, so outside the frame. Always see the original diagram. It's a request for all of you. Please see the original diagram to draw the SFD part, bending moment part always. Because in bending moment part, we are taking section either left or right. So we have to take either this part or this whole part also we can take also. This will get also the same answer. Okay. Now we are done with this first part. Now let's see the third part. Now let's see, we have done with this part AB, and now we have to calculate BC part. Now we have to separate the BC part. When we have to separate the BC, cut it over here and cut from here. Okay, now how will it come? It will come like this. Okay, this will come like this. Now see, now see this part. See this B part going downward to balance this part. To balance this part in this one B will be go B and C. This will, if this one is downward, to balance B part, this direction will be go upward. See, this one will go upward. 2.86. Okay, now or you can directly balance with the original diagram. See, this is your 2.8, directly transfer over here. Now but in C you cannot transfer over here, so in while seeing the B you have to balance the C part, neglect this part. Okay, now see, we have got this value, and see in this one here there is no value, so this is 0, so here also will come get 0. Okay, now when this 2.86 is going up and 10 kilonewton is going downward, now how it will come like this? See, 10 minus 2.86, how it comes? 7.14. See, 10, because this is downward, plus minus 2.86, what will it come? 7.14. Okay, now 7.14 going upward. Now see, this one is also 7.14 balance. Now see, 7.14 plus 2.86, nothing but 10. 10 is going from downward, so 10 is coming from upward. Now this part also is balanced, and this is also have 0 because there is no value over here. Now draw the SFD and BMD. Always extend the diagram. Now see, first what you have to do, draw the AFD part. This is your B, this is your C. Since there is no compression and tension load, no compressive load over here, so AFD will be 0. AFD will be 0. Okay, AFD will be 0. Now what the next part will be? Shear force diagram. Okay, see, in this one, if you want, you can calculate the shear force diagram over here also. See, shear force calculation. This part is positive. Okay, see, shear force B at left equal to 0. Shear force B at right equal to, see, we are taking section over here. Okay, now this will come positive, so 2.86 kilonewton. After that, we are taking, see, take it name as this one as F part. Okay, shear force F at left means over here we are taking this side only. This is also 2.86 kilonewton. Now shear force F at right, we are taking section over here and seeing here or here only, we can see over here, so this will come 2.86 minus 10, this will come minus 7.14. okay, kilonewton. After that, shear force C at left, it's come minus 7.14 kilonewton. Shear force C at right equal to 0. Now draw the SFD diagram. Now we have, see, we have written over here, you can directly solve over here also. Okay, diagram. Now draw the diagram. See, this is start with 0 and 2.86 plus 2.86 plus will be go something over here. Okay, 2.86. Now this from this side, this will come 2.86. Now after that 2.86, see this will go minus 7.14, so this will get minus 7.14. Now from till here it also same 7.14. Now see this value will get 0, so this will come 0. Okay, we are done with it. B and C part. This is positive outside the frame, this is negative inside the frame. As you see in the diagram, see this part will come outside the frame, this part will come inside the frame. By inside coming because this is minus sign. Okay, now after that we have done with this part. Now draw the bending moment diagram. Now in bending moment diagram, as you all know, we have to see the original diagram given in the question. Okay, now see, we have find bending moment at B, so directly apply this bending moment, don't need to find after that also. Okay, so directly apply bending moment at B. See, we have find over here bending moment at B, what will come? 30 kilonewton meter positive, so this will 30 kilonewton meter over here, 30 kilonewton meter. Okay, this will come over here positive. Now we have to find bending moment at F and bending moment at C. Now how will you find? See, bending moment, see we can find over here bending moment calculation. Okay, bending moment at B is equal to 30 kilonewton meter. We can find previous type. Okay, now bending moment at F is equal to, now how will you find bending moment at F? See, we have to find bending moment over here F. We have to see the original diagram. See, you can take this part or you can take this part. Okay, if you are taking this part, this will come directly. You have to take this part. See, this is come 17.14 and distance will be 3 plus 2 5. 17.14 into 5 positive, 17.14 into 5 is equal to 35.7 kilonewton meter. Okay, now bending moment at C. Now C will be 17.14 into 3 is nothing but 21.42 kilonewton meter. Don't panic over here because in this pictures, see this, if we are taking bending moment at F, not taking this side, because we are taking this side, this will come this distance, this will also come this distance, this is also correct, but we are taking this because it is very not complicated. So 14.14 force into perpendicular distance will be here like this 5. Now we are taking bending moment at C 17.14 into this distance. Okay, now see 21.21. Now draw the diagram over here. Now see, in F bending moment will be 35.7. This will come over here or something. Okay, now 21.42 something over here something 21.42, and this value will be 35.7. 35.7 in UD. If shear force diagram is straight line, in UD, in bending moment diagram it is inclined line. Okay, now how will you come? See, it will come like this. Okay, this is the positive outside the frame positive. This is your bending moment diagram, and this is your SFD shear force diagram, this is your axial force diagram. Okay, now we have done with the part BC. Now what's our next part? See, now take the consider part CD. Now CD part is inclined. See, don't take tension over the inclined part. This is also very simple, just you have to resolve the part. Let's I'm explain you. See, CD part, first draw the diagram over here. See, CD part, first draw the diagram. Okay, now see, you know the value of this over here. Okay, now see, when we are taking BCD part, always see this part only, not see this one also. Okay, because we have to taking consider part CD only. So now 17.14, while seeing this you have to balance the C part, but here this is not this is not possible for us, because we have to, while drawing the AFD and SFD, we have to take the axial force diagram. Okay, so in axial you have to resolve this for 17.14. now how will you resolve? Let's see, always from this types of problem, always extends the as much as possible. See, extend this one also, extends this part also, extend this one also. Okay, now see, now all we have extend, and extend this one also. Okay, now see, we have know that. See, how will you find this theta? We have to find this theta first. This theta, this will come theta, this will come theta, and this will come theta. One and after come will be theta will be same, as you all knows. Now how will you find this theta? To find this theta, we know the value of this and we know the value of this. This is 3 and this is 3 and this is 4. Sorry, this is 3 and this is 4. Now how will you find the theta? We know the distance, we know the distance. Now as you all knows, tan theta is equal to opposite upon adjacent, and theta will be tan inverse of 4 by 3. While solving this you get the value 53.13. okay, your theta will be 53.13 degree. Okay, now our theta will be 53.13. so now see, in part D we have to take the horizontal part and vertical part, VA and HA. Okay, now how will we come this like this? See, this 71.14 resolve over here, this one, this will come like this, because we want the axial force diagram, that's why we need this part, and resolve this part is like this here. Okay, this part, and this arrow will go here, this arrow will go here, because this is your axial diagram, this is your shear force diagram. Okay, now see, 17 point, how its value will become 17.14. see, we are resolving this to this here, because here is no theta, sorry, here is no theta, so 17.14 sine 53.13, okay, is equal to 5.71 kilonewton. Now this value will become, see, this is with theta, as you all know, the angle with theta, the force with respect to theta is cos theta, cos. Now 7.14 cos 53.13 is equal to 4.28 kilonewton. Okay, now you want this value 5.71 and 2.48, not this value 7.14. okay, now take one more FD of that part. See, first resolve this part. Okay, now draw one part, also draw one part neat and clean. Okay, now we have to know this value. This value is nothing but 4.28. we know that this value also 5.71. okay, now how will you resolve? See, 5.71 coming from this side, directly apply over here, 5.71, this will go 4.28 over here, so here we have to downward this force 4.28. now this part also will get balanced. Okay, this is your C, this is your C part, this is your D part. Now we want this value and this value. Now we have balanced this over here and balance over here. Now we have done with this. Now directly draw the AFD and SFD. Now how will you draw the first AFD? How will you draw the AFD? See, this is going, See, this is compression. See, compression means minus. Minus is nothing but inside the frame. Means you have to draw inside the frame. So this will come over here like this. Inside the frame. Okay. This will come like this. How much it come? 5.71. 5.71. Okay. Now this is minus sign or compression AFD. Okay. Now draw the SFD part. SFD part. This is your D, this is your C. Now see, this 4.28 coming upward and this 4.28 coming downward. Okay, now see. Now how it will come? See, this will come down 4.28 and this will going up 4.28. Directly draw the diagram. This is also minus, this is SFD, or directly, or you can solve over here also. Shear force C at left equal to 0, shear force C at right equal to 5.74 minus, okay, minus sign. Now draw the bending moment diagram. Now this is D part and this is C part. As previous sum, you calculated bending moment at C. Always see the original diagram for bending moment at C. Always we have already we have calculated bending moment at C. See, this bending moment value will be, bending moment at C value will be 21.42. Directly solve over here. This positive. Directly solve over here. 21.42 kilonewton meter. Okay. Now what about bending moment at D? Bending moment at D will get 0 because in here there is no what, you can take this part or this part. We are taking this part, there is no load, so 0. So directly draw the diagram directly over here. This is nothing but positive. Positive means outside the frame. This is your bending moment diagram. Okay. Now we have done with this all four parts. See, now this is your main diagram. We are done with AB part, we have done with BC part, and we have done with CD part. I hope you will understand my video. Always, I hope you understand my video. Thank you. Thanks for watching.